Welcome to the Platform Engineering Playbook podcast, where everything you hear is built, reviewed, and improved by AI, by me, and by you, the listener. This show keeps me, and hopefully you, up to speed on the latest in platform engineering, SRE, DevOps, and production engineering. It's a living experiment in how AI can help us track, explain, and discuss the fast-moving world of infrastructure. Every episode is open source. If you've got something to add, correct, or challenge, head to platform-engineering-playbook.com. You'll find all the content and a link to the GitHub repo. Open a pull request, join the conversation, and make the playbook smarter. Let's get into it.
Today, we're diving into one of the most ambitious GitOps scaling stories ever told. Okta took Auth0's private cloud from 12 Kubernetes clusters to over 1,000 in 5 years using ArgoCD. It wasn't smooth, it wasn't simple, and the lessons they learned at KubeCon 2025 are invaluable for anyone managing multi-cluster infrastructure. But first, let's run through some important news from this week.
Helm released 2 maintenance updates. Version 4.0.4 and version 3.19.4 are both available. These are stability releases with bug fixes. For platform teams managing 1,000 clusters like Okta, rock-solid package management isn't optional. Helm remains the backbone of Kubernetes deployments.
D-Zone DevOps published a practical guide on zero trust in CI/CD pipelines. It covers identity verification, least privilege access, and continuous validation. Here's why this matters for GitOps. When you're deploying to 1,000 clusters via ArgoCD, your CI/CD pipeline is your security perimeter. A compromised pipeline means a compromised fleet. This guide is worth your time.
And an engineering team shared how they migrated 1 billion database records from DB1 to DB2 with zero downtime. The patterns are remarkably similar to multi-cluster GitOps challenges: incremental migration, continuous validation, rollback safety. Whether you're scaling databases or GitOps deployments, the fundamentals are the same.
Microsoft announced Azure HorizonDB, a new Postgres-compatible database service. It's competing directly with AWS Aurora and Google Alloy DB. For multi-cloud platform teams, this matters. Multi-cloud often means multi-cloud. Database portability is becoming a requirement, not a nice-to-have.
And finally, Platform Weekly published the State of Platform Engineering report for 2026. Salary trends, maturity models, and a shift toward lower-level infrastructure concerns. Speaking of platform engineering maturity, let's talk about what it takes to scale GitOps to 1,000 clusters. This is where theory meets reality.
Okta engineers Jérémy, Albuixech, and Kahou gave a talk at KubeCon plus Cloud Native Con in Atlanta. The title says it all: 12 to 1,000 clusters.
Let's set the scene. Auth0 offers private cloud for enterprise customers. These are organizations that need identity and access management but can't use multi-tenant SaaS. In 2020, Auth0 managed 12 Kubernetes clusters. By 2025, that number exceeded 1,000. That's 83 times cluster growth in 5 years.
And they bet everything on ArgoCD.
ArgoCD is a CNCF graduated project, production ready. It's a GitOps continuous delivery tool for Kubernetes. The pull-based model is more secure than traditional push-based CI/CD. It has native Kubernetes support, an active community, and a strong ecosystem. But here's the critical detail. ArgoCD was not designed for 1,000 clusters.
What does that mean in practice?
Let's talk about the challenges. First, controller performance degradation. The ArgoCD application controller is single-threaded for many operations. Research from the community shows that UI performance degrades beyond 1,000 applications. When you're syncing 1,500 apps across 50 clusters, sync times can reach 10 minutes. And that's without accounting for network latency. Clusters spread across global regions add unpredictable delays.
So the first problem is ArgoCD slows down as you add clusters.
Correct. Second problem, centralized versus distributed topology. Most teams start with centralized approach, one ArgoCD instance in a management cluster. It deploys to all your clusters. Pros, single pane of glass, simplified management. Cons, single point of failure, scaling bottleneck. At 100+ clusters, you hit a wall. You need controller horizontal scaling, you need sharding, and application sync times become unpredictable.
What's the third challenge?
Application and repository explosion. At 1,000 clusters, you're managing thousands of ArgoCD application resources. Git repository management becomes complex. Secret management at scale is painful. RBAC explodes. Who can deploy what to which clusters? Load testing shows that beyond 2,000 applications, you see clear performance issues. The UI becomes unusable.
And you mentioned sync times earlier.
Fourth challenge, sync performance and network geography. If your clusters are distributed globally, network latency varies significantly. Some clusters might sync in seconds, others take over 10 minutes. You need zone-aware scheduling. You need prioritization. You need to understand which clusters are critical and which can wait.
What about observability?
That's the fifth challenge. At 1,000 clusters, how do you answer basic questions? Which applications are out of sync? What's the sync success rate? Where are the bottlenecks? How do you debug a failed sync across 1,000 clusters? Traditional Prometheus metrics aren't enough. You need purpose-built observability.
So those are the challenges. What are the solutions?
Solution 1, controller sharding. You split the ArgoCD controllers across multiple replicas. Each replica manages a subset of clusters or applications. Benefit, horizontal scaling of the control plane. Trade-off, increased complexity. Now you have to manage sharding logic.
What about topology changes?
Solution 2, the ArgoCD agent. This is a hub-spoke model. An agent runs in each cluster. The central hub manages coordination. Benefits, reduces network chattiness, better scaling characteristics, fault isolation. Red Hat has published research on this for OpenShift GitOps. It's designed specifically for multi-cloud environments.
How do you manage thousands of application resources?
Solution 3, application sets and GitOps templating. Instead of manually creating thousands of application resources, you generate them from templates. You define patterns once. ArgoCD generates the applications dynamically. This keeps your repository clean. It enforces consistency across clusters, and it's easier to maintain at scale.
What about repository structure?
Solution 4, intelligent repository structure. The monorepo versus polyrepo debate is real. Do you keep everything in one repository or split by team, environment, or cluster? The answer depends on your organization, but the best practice is balance consistency and flexibility. Environment-based branching works for some teams. Cluster-specific overlays work for others. Test your patterns at small scale first.
And deployment safety?
Solution 5, progressive rollouts. Canary deployments across clusters. Roll out to 10 clusters, validate, expand to 50, validate again. This contains the failure blast radius. If something breaks, you've only impacted a small subset. And automated rollback on anomalies is critical. Don't rely on humans to detect failures.
Let's talk about lessons learned. Okta spent 5 years on this journey. What did they learn?
Lesson 1. GitOps doesn't solve organizational problems. GitOps is a technical pattern, not a silver bullet. You still need clear ownership. You still need RBAC. You still need approval workflows. Cultural buy-in is harder than technical implementation. If your organization isn't ready for GitOps, the tooling won't fix that.
What about scaling strategy?
Lesson 2. Start small, scale incrementally. Okta didn't jump from 12 to 1,000 clusters overnight. They went 12 to 50, then 50 to 200, then 200 to 1,000. Each stage revealed new bottlenecks, new failure modes, new operational challenges. Don't try to solve for 1,000 clusters on day one. Validate your patterns at smaller scale first.
How do you know your patterns work?
Lesson 3. Load testing is non-negotiable. You must test application sync performance, UI responsiveness, controller resource usage, network bandwidth requirements. Tools like vCluster let you simulate scale. If you wait until production to discover that your ArgoCD setup can't handle the load, you've already lost.
What metrics matter?
Lesson 4. Observability unlocks confidence. Track sync success rate per cluster. Time to sync at P50, P95, and P99. Application health across the entire fleet. Git pull frequency and its impact on your repository. Without these metrics, you're flying blind. You can't diagnose issues. You can't predict capacity. You can't make data-driven decisions.
Is ArgoCD the only tool you need?
Lesson 5. ArgoCD isn't the only tool. The ecosystem matters. Helm for packaging, Customize for configuration management, External Secret Operator for secret management, Policy as code with OPA or Kyverno. GitOps is a pattern. ArgoCD is one implementation. You need the right tools for each layer of the stack.
What about ongoing operations?
Lesson 6. Plan for Day 2 operations. Upgrading ArgoCD across sharded controllers, migrating repositories without downtime, disaster recovery for 1,000 clusters, on-call runbooks for GitOps incidents. Most teams focus on the initial deployment, but you'll spend 95% of your time on Day 2. Plan accordingly.
Let's make this practical. What does this mean for teams at different scales?
If you're managing 10 to 50 clusters, you're in the sweet spot. A single ArgoCD instance can handle this. Focus on repository structure and RBAC. Invest in observability early. Don't wait until you hit scaling problems. Build the muscle memory now.
What about 100 to 500 clusters?
You're entering the warning zone. Start planning for sharding now. Load test your ArgoCD setup before you hit production issues. Consider hub-spoke architecture with ArgoCD agents. Automate everything. Rollouts, validation, rollback. Manual processes don't scale beyond 100 clusters.
And if you're managing 500-plus clusters?
You're in Okta territory. Sharding is mandatory. You need to decide ArgoCD agent or alternative topologies. You need a dedicated team for the GitOps platform. This isn't a side project. Observability is mission critical. You cannot operate at this scale without real-time dashboards, automated alerting, and incident response playbooks.
What are the universal takeaways, regardless of scale?
5 things. First, GitOps is a journey, not a destination. It evolves continuously. Second, incremental validation beats big bang deployments, always. Third, observability unlocks operational confidence. You can't improve what you can't measure. Fourth, organizational readiness matters more than technical readiness. Culture eats tooling for breakfast. Fifth, community matters. Learn from teams like Okta. Read their talks. Study their patterns. You don't have to solve these problems alone.
Let's wrap with key takeaways. First, Okta's 5-year journey from 12 to 1,000 clusters proves GitOps scales, but it requires continuous evolution, not set it and forget it.
Second, ArgoCD has known scaling limits. Beyond 1,000 applications or 100-plus clusters, you'll need sharding, load testing, and architectural changes.
Third, centralized GitOps becomes a bottleneck. Hub-spoke models with ArgoCD agents offer better scaling characteristics.
Fourth, observability is the unlock. You can't manage 1,000 clusters without real-time sync metrics, health dashboards, and automated alerting.
Fifth, start small, validate patterns, scale incrementally. Okta didn't solve for 1,000 clusters on day 1, neither should you.
The fundamentals of GitOps remain constant, but scaling to 1,000 clusters requires intentional architectural choices, continuous load testing, and operational discipline. If you're on this journey, you're not alone.
That's it for this episode of the Platform Engineering Playbook podcast. Every topic, transcript, and summary you just heard lives out in the open at platform-engineering-playbook.com, where anyone can suggest updates or add insights through GitHub. If you've got thoughts, fixes, or new ideas, open a PR. And if you enjoyed the episode, rate us on your favorite podcast platform. We're always shooting for 5 stars. While you're there, give the project a star on GitHub. It helps others find and contribute to the Platform Engineering Playbook. This podcast is generated by AI, reviewed by AI, me and you, a community of engineers keeping our craft sharp. Thanks for listening. and see you next time inside the Platform Engineering Playbook.